Albert Einstein's theory of relativity revolutionized our understanding of time and space. According to his equations, time is not absolute, but bends under gravity, creating the possibility of time dilation. Wormholes, hypothetical tunnels through spacetime, could theoretically connect distant points in time. While no wormhole has been observed, their mathematical validity keeps them at the forefront of theoretical physics. Scientists speculate that traversable wormholes would require exotic matter with negative energy to remain stable. This foundational concept opens the door to exploring time travel's scientific plausibility. In 2022, quantum physicists simulated a microscopic wormhole using entangled particles, marking a milestone in time travel research. This experiment, conducted at the California Institute of Technology, used a quantum computer to model how information could traverse a theoretical wormhole. While not a physical gateway, the simulation demonstrated the principles of space-time manipulation. The team observed particle behavior mimicking theoretical predictions, sparking excitement and skepticism. This breakthrough hints at the potential for future experiments to explore larger-scale phenomena, though ethical concerns loom over practical applications. In 2045, Project Kronos launched the first human time travel experiment. A volunteer, equipped with a prototype temporal pod, aimed to travel 24 hours into the future. The pod, powered by quantum entanglement and negative energy, vanished in a flash of blue light. Scientists monitored the event with bated breath, but the pod reappeared empty, except for a cryptic note dated tomorrow. The note contained precise details about an unforeseen lab accident, raising questions about predestination and free will. This test ignited global debates on the ethics of tampering with time. The grandfather paradox illustrates the logical conundrum of time travel. If you go back and prevent your grandfather's meeting with your grandmother, you would never be born. But if you were never born, how could you travel back to alter events? Theoretical solutions include the idea of parallel timelines or self-correcting universes. In 2047, a time traveler's accidental disruption of a historical protest led to their gradual disappearance from family records. This real-world example fuels arguments that time travel, if possible, must operate under strict laws to avoid catastrophic paradoxes. Minor changes in the past can trigger cascading effects, altering the future unpredictably. In 2048, a time traveler's removal of a seemingly insignificant artifact led to the collapse of a major city's infrastructure decades later. Scientists observed these temporal ripples through advanced simulation models, revealing how small disruptions amplify over time. The phenomenon mirrors chaos theory, where a butterfly's wings could cause a hurricane. This insight underscores the fragility of history and the immense responsibility of time travelers to avoid unintended consequences. The Bootstrap Paradox occurs when an object or piece of information is trapped in an infinite loop with no origin. In 2050, a physicist received a handwritten equation from her future self, enabling a breakthrough in fusion energy. Yet the equation's origin remained a mystery. It had no creator. This paradox challenges the linearity of cause and effect, suggesting that time loops could exist without violating physical laws. While fascinating, it raises philosophical questions about predestination and the nature of innovation in a universe where knowledge can emerge from nowhere. After a timeline fracture in 2051, scientists and historians collaborated across decades to restore the original sequence. Using synchronized chronobeacons, teams pinpointed critical anchor points in history that needed reinforcement. The operation required precise coordination, as any misstep could worsen the damage. In a climactic effort, they stabilized the timeline by ensuring a key political speech was delivered as originally recorded. This unprecedented teamwork highlighted the potential and peril of temporal engineering, where salvation and catastrophe hang in a delicate balance. Stranded in a dystopian 2075, a team of time travelers hid among the populace while searching for a way home. The future they encountered was unrecognizable, a world reshaped by their own meddling. Advanced surveillance drones patrolled the skies, forcing the team to adopt disguises and forge identities. Their only clue was a hidden message etched into a monument, seemingly left by their past selves. This ordeal underscored the isolation and vulnerability of time travelers, who risk becoming permanent exiles in eras they cannot comprehend. In 2052, global leaders convened to debate the fate of time travel technology. Declassified reports revealed near-miss paradoxes and timeline collapses, prompting calls for a permanent shutdown. Proponents argued for controlled use in medicine and disaster prevention, while critics warned of existential risks. The final vote hinged on a haunting question: is humanity mature enough to wield the power of time without self-destructing? The decision to halt research left a chilling legacy: a red abort button sealed behind glass, a symbol of restraint in the face of infinite temptation. By 2055, the timeline had reset, erasing most traces of the time travel experiments. Yet, in a classified archive, a dusty folder labeled Project Chronos contained sketches of wormholes and handwritten notes warning of paradoxes. The file's origin was unknown, but the equations matched those from the original 2045 test. This eerie discovery suggested the loop was never truly broken, only delayed. As a young scientist stumbled upon the folder, the cycle poised to begin anew, blurring the line between discovery and destiny in the eternal dance of time.